Welcome, everybody, to this month's meeting of GlugNet. Tonight, we have a special treat to start off. We have a lightning talk by Mr. Zoltan Lahovsky. So, Zoltan, take it away.
All right. Yeah. Thank you very much. I'm very happy to be here with you because I wanted to show you something that's perhaps out of the ordinary, how you can use your .NET knowledge to pretty much create computer chips. It's almost like magic. But before going into that, a little bit of intro. I'm from a company called Lombic Technologies. We are mainly doing web development with the Orchid Core content management system, by the way. So if you are a web developer using .NET, ASP.NET Core, check out Orchid Core. It's a great CMS. And we are using it with even clients like Live Nation, the Smithsonian Institution, or Microsoft itself. But when we are not doing web development, then we are doing some research and development, like our Hastlayer project that I would like to show you now. But before that, a little bit of you. Let's talk about you first. Let's suppose that you are doing some number crunching. All right, so something compute bound or memory bound, some high performance or very hardcore computations. For example, AI, machine learning, pretty popular topics nowadays, or perhaps something with image or video processing. That's those two usually can come down to the same things, by the way, to an extent, or perhaps computer vision. Maybe you are doing algorithmic trading on the stock market, quite interesting space as well, with nanoseconds to spare, or perhaps data compression, or something maybe in the cryptography or perhaps even cryptocurrency space. Well, then to make that number crunching faster, you have a few usual steps to take. First, we all know that you figure out what's slow and try to optimize it. Let's suppose that you have already done that. Next step that you can perhaps take is to parallelize it. Use multiple threads with the task parallel library of .NET, or use operation level parallelism with vectorization, pretty much doing like 4 multiplications at the same time. Let's suppose that you have already done that as well. And finally, of course, you can scale up or scale out. So you can use more computers, which in the cloud is quite easy, or you can use bigger, faster computers, which in the cloud is pretty easy as well. Now, let's suppose that you have already done that as well, or it's not feasible to go further. So you can throw a lot of money at a problem, but it doesn't make sense all the time. Now, what if you have already done that and you're still not quite happy with the performance? Then you can use a heterogeneous computing approach. Now, even if you are not working on this, you surely have utilized the fruits of heterogeneous computing, because at least your PC has a GPU, a video card, or at least an integrated video chip. But perhaps you haven't worked with FPGAs before. Now, let's talk about FPGAs a little bit. First of all, what's that? What's the acronym? What am I talking about? FPGAs, or field programmable gate arrays, are pretty much computer chips that can behave like any other computer chip, within limitations, of course. So that means that they can be dynamically rewired on the fly. For example, if you want to have, I'm simplifying things a lot, but if you want to have a chip that computes some machine learning algorithm, then you can configure an FPGA to do that. Or if you want to do some image processing in a hardware accelerated way, then you can also configure an FPGA to that instead, the same FPGA. Now, if you haven't worked with FPGAs before directly, I believe you still somehow even indirectly use them, because, for example, if you Google something on Bing, you have used them. Bing is accelerated by FPGAs. I'm not sure about the new Bing though. Azure uses FPGAs for hardware accelerated networking, but they are sometimes also used in household appliances like routers or less household appliances like X-ray machines or self-driving vehicles. But you need to be a hardware engineer to utilize them because it's hardware engineering. And talking about how to work with these devices, let's compare them a little bit, because FPGAs have some unique benefits that we want to utilize. That's the whole point. So let's compare CPUs, processors, and GPUs, so what's in the video cards, and FPGAs a little bit. Let's talk about parallelism first. Now, so how many things these devices can compute in parallel? And I would say that CPUs are on the lower end here, couple dozen, perhaps 64 cores. GPUs are on the other extreme. They are very parallel, very highly parallel devices with thousands of little processing cores. And FPGAs are kind of in between, although they don't really have cores usually, but we'll talk about that a little bit later. Now, when it comes to the complexity of programs you can run on these, the differences in, or the advantages are in the other way, because CPUs can run anything, while GPUs are very limited. And FPGAs are again in between. While if you talk about power efficiency, that's where FPGAs really shine. So how much computation you can do with 1 watt of power. And of course, when we are talking about power, we are not just talking about having to consume power because you are perhaps in an embedded device, so there's a battery you have to keep track of, or you just want to do something good for the environment. But this is all costs. Power is costs because it's actually cost twice. Because first you pay for power, and secondly you pay for dissipating all that heat, for the cooling. The FPGAs have a sweet spot there, but they are very hard to utilize, as mentioned. You have to possess hardware engineering knowledge, because when you are working with an FPGA, you are not programming a processor. You are creating a processor. You have to think in terms of gates and wires and clock cycles. It's super low level. Compared to CPU or even GPU programming, it's much harder. But with tools like Hastlayer, we intend to bring this complexity down onto the software development level. So, what is Hastlayer then? It's a tool that takes a computer program and turns it into a piece of FPGA logic. Now, in the tagline version, we say that it takes a computer program and turns it into a computer chip, but that's a simplification, as you now can understand. And of course, not just any programs. We are at the .NET meetup. We are talking about .NET programs, and actually .NET. So Hastlayer processes .NET assemblies, not C# code, but the assemblies. So that means that, at least in theory, any .NET language can be used. We have C# and F# examples in the SDK, which is up on GitHub, and I will show you the link to. But in principle, any other .NET language can be used as well. So all in all, with Hastlayer, we can get the computing benefits of FPGAs for all of our software developers. So first, you can get a performance increase if your computation is highly parallelized, compute bound, or memory bound. Secondly, you get a higher power efficiency, a smaller computing cost, and it's still software development as usual. So a lot of talk until now. Let's check out a demo. And I'm switching over to Visual Studio, and this is kind of an exaggerated example of an algorithm that's especially suited to be accelerated with Hastlayer and with FPGAs, and that I will also run in a minute. What this is that, well, it's called parallel algorithm, so you might guess what it's about. It's something not real life, again, an exaggerated example. What it does is that it's basically some simulated number crunching. There's a loop that runs 10 million times, some logic inside. Basically, we are simulating that we are doing some number crunching here. This could be a Monte Carlo algorithm to compute something from science or engineering. This could be an image processing task. We also have examples of those, but this is a simpler one. And the point here is that all this supposed number crunching is done in tasks. Now, I guess everybody here knows about tasks, but you can think of them as kind of threads. Although it's important that tasks are an abstraction over threads, so .NET will manage them and make sure that you are not oversaturating the CPU. And that's important because we are starting this many tasks here, which is actually 260. Why 260? Because on the device I will run this, there will be only a 2-core ARM CPU. Now, I probably piqued your interest by an ARM CPU, but 260 tasks, 260 copies of this number crunching algorithm will actually fit on the FPGA part. So on the FPGA, we'll be able to utilize a hardware level parallelism of 260. On the hardware, this whole thing won't run on a 2 or 4 or however many core CPU, which is definitely fewer cores than 260, but it will be turned into kind of a processor with 260 cores. Now, that's a lot. And depending on your algorithm and the CPU that you are testing against, this can bring some huge performance and power consumption benefits. So let's actually run this. By the way, there's still a little bit of code after there because we actually was wait for all of these tasks to finish, and then an output is generated from the computations of all of these tasks. And now I will run this. By the way, again, this code is in the open source SDK, which is available on GitHub. I will show you the link to it. And now I've opened a terminal window because I'm actually connecting to this device here. This is the same thing that goes on board of a satellite. This is an onboard computer for a satellite. Because as a .NET developer, you might not knew that, but as a .NET developer, you can also write programs for spacecraft. And it runs a little Linux, what I'm connecting to now, and I'm running a demo application. What this demo application does is that it generates the hardware implementation, and then it starts a software execution. The software execution will run on that mentioned 2-core ARM CPU. This is an embedded device. It runs on something like 1-2 watts at most. So that's we are talking about an ARM CPU and the small one. And once that software execution finishes, which it just did, then it will execute the same thing on the FPGA part of this device 3 times. This is a device, by the way, called Zinc. That's the brand name, which is an ARM, which contains an ARM CPU and an FPGA in the same chip. So let's see the results. Here's the CPU execution, which took around 25 seconds. So pretty long. And let's check out the hardware execution, which will have some details here. Yes, which took around 300 milliseconds in total and 240 milliseconds if we just take the computation itself into account without talking to the FPGA. So it was about 100 times faster. That's quite a speed up. Now, of course, this was just an example, but I wanted to show you what can you achieve with hardware acceleration like that. 100 times speed up. And this 100 times speed up is not just time, but also money, which is kind of the same thing, of course. So that was the quick intro to Hastlayer and you being a hardware engineer that you didn't know. So if you like this, and I really hope you did, here's the link to the SDK. I will also post a comment about it or with it under the meetup. And be ready because FPGAs are now available in all major cloud providers. I think they will be even more prevalent in the near future. And you as a .NET developer can already use them. So if you do, please get in touch with me. I will be happy to help you if I can and learn about what kind of use cases you can have here. So thank you very much.
Thank you very much, Zoltan. Very interesting.
Yeah, thank you. Yeah, I have to say it's something I've never seen before. Very, very interesting.
I'm glad to hear.
Okay. Okay. A few housekeeping items, and then we will proceed with our main presentation. A little bit about GlugNet. We are the Greater Lansing user group for .NET developers, based out of Okemos, Michigan, as pictured on the map here. Our meetings are held every month on the third Thursday. They are free and open to the public. The best way to learn more about us and what's coming up is if you go to our meetup page. That's meetup.com/glugnet. We just had a lightning talk, but if you are interested in giving a lightning talk in the future, we are looking to put 10 to 15-minute lightning talks at the start of our meetups. So if you're interested, you can reach out to myself, Stephen Ball, or to Joe Kunk, and we will get you scheduled. At this point, we would like to thank our sponsors for the evening, NIS Technologies, who is providing this go-to session, the .NET Foundation, who helps pay the bills for the organization, and TechSmith, who is our normal physical hosting site. Meetups are recorded and posted to YouTube by Sam Nasser. You can find his channel by either using this QR code on the screen or going to youtube.com/@SamNasserMVP. During tonight's presentation, we want this to be interactive, but we also need to be able to hear our presenters speak. So if you are not asking or answering a question, we ask that you please stay muted. If you don't feel like speaking up but still have a question, there is a chat feature in GoTo. You can submit your questions there as well. I will moderate that and make sure that those get to the speaker. At the conclusion of tonight's presentation, there will be a survey to give our speaker feedback. All the feedback we collect is anonymous and gets sent directly to our speakers so they can improve their presentations going forward. So we would really appreciate all the feedback, good, bad, indifferent. We want to hear about it. And finally, some additional meetups that you might be interested in because you've attended this group. Our friends at the Cleveland C# VB.NET user group, the Greater Lansing area for SQL Server. There's a .NET study group. There's also an in-person meetup based out of Southfield, Michigan, called mi.net. So if you're in the Southfield area, you may want to check that out. All right, so Joe, I will make you presenter. And it's all yours.
Thank you. I think you didn't do Michigan proud, Stephen, when you introduced Lansing. Aren't you supposed to do something like that? Like you're from here and the meetup group is here. I'm right here now. I'm actually in Detroit this week, so know the whole Michigan mitten thing.
We do carry a map everywhere we go. That's true.
I posted in the chat where you can get the slides from. There's going to be a little bit of talk from me, and then we're going to get some code a little bit. Let me hit play. Okay, I can't see the chat right now, so if there are any questions, feel free to blurt them out. My name is Joe Guadagno. I am what we call a senior director here at Rocket Mortgage Technology based out of Detroit, even though I live in sunny Phoenix, Arizona, where it's about 120 billion degrees right now, and it's a nice 60 and rainy here in Michigan. We're here to talk about the Uno platform, write once and run anywhere. Oh, and on the side, I'm also the current vice chairman for the .NET Foundation. And I think the previous speaker, Zoltan, has his project Orchard Core in the .NET Foundation. A little bit about me, I already talked about. I'm a senior director in technology. I organize a conference in the Arizona area called Desert Code Camp. I'm a Microsoft developer MVP, and I am, more importantly, a father of two, husband to one, which means I am always wrong and usually poor. A couple of different ways to reach out to me on Twitter, Facebook, LinkedIn, YouTube. You can find a lot of videos on me on YouTube, GitHub for some of my sample repos, my website, which has blog posts usually around the topics that I present about, or Hotmail if you want to reach out to me. I'll also show this at the end when we're done. So let's go to the agenda. First, we're going to cover what is the Uno platform. What does the Uno platform provide? Kind of how to get started, and then for the last 10 or so minutes, we're going to do a couple of demos using the platform. So first, let's get started with the platforms. But before we talk about the platform, let's talk about the problem. The problem right now, as Zoltan was pointing out, there's lots of different ways to do development depending on what you're writing to. .NET, aka .NET Core, aka .NET, tried to solve that problem with the new version of what was .NET Framework by trying to be able to write code on a Windows PC or a Mac PC and have it run on Windows, Mac, or web. That works well for console apps or web apps. It doesn't work well for anything that really requires a user interface. And that's kind of where the Uno platform comes in. If you're a software organization like a Rocket Mortgage or something, you're probably writing an app that works on an Android device as well as an iPhone. Those are two common mobile platforms. But you might also want that device to work on the web or work on a Windows PC or a Mac PC, depending on your thing. So if you think of something like Microsoft Office, or now in our current world, we have Microsoft Teams or Zoom or GoToMeetings. Most software organizations don't want to have to write 7 different versions of it, because what ends up happening when you write 7 versions, you have 7 different versions of the app, because iOS only supports this kind of swiping or only this icon metaphor. The Mac supports 3-finger swipes, but the Windows PC doesn't. That's kind of where Uno comes into play. You can write your code once and you don't duplicate the effort. You're writing it once and running it everywhere. It allows you to take legacy apps that are commonly written in C# and VB and migrate those over. In the past, you've had a lot of migration costs of, hey, now I got to write it in .NET and I got to migrate it over to .NET Core or new .NET. I have to write a version for iOS, etc. And then you have skills that are always a problem. I have so many developers that only know one technology. Do I have to hire another one to learn iOS, another one to learn Android, etc.? So the solution comes into play is using the Uno platform. You can write your application once using XAML and C# and deploy it anywhere. So as we see here, we have the XAML mixed with the Uno platform. Then you can run it on a desktop, on the web, on a iOS device, on a Windows device for the 3 people that still have Windows phones, but any Windows phone like a Surface or anything like that, an Android, Xbox, pretty much anywhere you can. And that's because they all use .NET behind the scenes. So let's take a look at actually how they do that. So you start off with the Win UI. That's where most of the work happens. So Microsoft has written a bunch of cross-platform UI components, things like a data grid, or a slider box, or a text box that run anywhere. The Uno platform then kind of transforms all that together to run cross-platform. So that sits on top of XAML and C++, which run on .NET. And then it uses different things to kind of get it to work on the platform. So on the Windows PC, which is this light blue, it will basically run the Windows UI, so it doesn't really have to do any transformations. On the web, it uses HTML5, so it converts the sliders and desktops into HTML5 based components, text boxes and things like that to run there. For iOS, it uses AppKit to run on Mac machines, or the UI kit to run on your iPhones. And then it uses the views within the Android ecosystem to display that. And for Linux machines, or things that have a UI like an Alexa, Google Home, or certain laptops like a Google Chrome book and things like that, it uses a technology called Skia, or Skya, depending on who you talk to, that takes that and kind of translates it into Unix. And what does that really provide you? It really gets you pixel perfect output. When you design it on one screen, it looks almost exactly the same on the other. And the reason why I say almost exactly is because some form medians, because of stretching and stuff like that, changes a little bit. Like you'll see in a web app that we're going to demo later. The web app, depending on how I stretch and shrink the screen, proportionally might do. But if you did the same thing on a Windows app, it will look like that. You have a single code base. I run my code once we see the new file. All my business logic is in one place. And then all the other Android, iOS, Windows, etc. are in separate, but they're only in separate to control the platform-specific things like any images that are needed or any extra properties that are needed. Runs anywhere .NET runs, and it's free and open source. It's totally free. There's no licensing for it. They work similar to a lot of the newer models with open source, that there's paid support in the event that you're having troubles or struggling. So if you're a large organization, you're not comfortable using open source, and the organization might go away or something, you can pay for the support model and have, I don't know if it's 24/7, but there's multiple different support packages available. So let's see what the platform buys us. So like I said, again, it works on Windows, the web, macOS, and Linux. So there's a combination of themes, extensions, works with different toolkits and Figma out of the box that, again, translate into the different environments. And it's truly native. Like I said, there's a translation that happens when you build that uses Windows UI or the UI kit or app kit or views, etc. when you're building it. So I keep saying it builds the same app. It's universal. It works over and over depending on your platform. Let's go take a look at what that looks like. So here's a sample code. I'm taking a grid that's white, adding a 50, adding a text block here that has a binding element to this slider. So basically, as I slide the slider, the number increases. Now, as you see here on Linux and Mac, because I didn't specify a min and max value, it just did 0 to whatever the highest number is. But on an iOS, Windows, Android, and web, the default app is 100. So the slider is a little bit more, a little bit different looking. But that's because it's following whatever the standards are for that operating system that it's running on. I talked about the license already. There's paid enterprise support, and it's free open source software. You can download it, you can make your own version of it. I've submitted a couple of pull requests to it already. So let's see what the platform provides. It's free, but let's see what do I really get out of it. So let's talk about the XAML support. There's control templating and data templating, which we kind of saw a little bit a couple of slides ago with navigating to the slide where we moved it and it said 42. You'll see in some of the upcoming examples, we'll bind it to a web service in a little bit. You get styling and theming. There's a couple different themes out of the box. There's a Fluent theme and a material theme. So if you want to follow like the Android-based theming or the Microsoft-based theming, you can. You can style components across the board. You have conditional XAML that allows you to set things like if this field is popular, do this, otherwise do that. There's native control integration, so you have access to the camera controls. If there's a camera available for the unit, if there's something that's special to that, you have access to it. You can do conditionals like if Android or if or compile time things, if Android this, if iOS do this, if there's particular controls for that thing. But although it supports the ability to do that, you generally don't want to do that because then you're starting to gear away from your one code base. It's quite a few animations, both visual state and state users can hit a button to save something, and you can have an icon that's like pulsing a save, or same thing with visual states. We kind of talked about data binding and property inheritance. We'll see more of that in example. There's shapes and brushes also. So everything you expect from a XAML app, if you've been building anything with WPF in the past, or Windows UI 2 or 3, you'll get that, or even Universal Windows Platform. So let's take a look at some of the components that are available out of the box. It's a lot. Now this list is a little dated. It's about a year old. There's a lot more added. You'll also notice a couple of updated. So some things have updated. Some of these are components out of the box. There's also a separate toolkit called the Windows Community Toolkit that adds even more components to it. Things like the data grid here, or the split view, the person picture view, which we're going to use a little bit coming up in the samples. So if you've done any Windows Forms development, you can basically take that skill set and move it over to here. Let's take a look at some of the themes. So Fluent UI on the left, Material in the middle, and then the iPhone Cupertino. Now you can select these things and have your app look that way across the board. So if I like the material look, I can make the material look stand out on my iPhone app, on my Windows desktop, or my Android app. You can do the same thing with the Cupertino or the Fluent UI, your choice. Or you can have it dynamically select based on the area. By default, if a theme is not selected, it's just going to use the native look and feel. So let's take a look at some of the animations. See the one on the left right here, we're doing animations around transitions, page navigations, etc. The one in the middle, we're showing navigations when a person's phone number or verification code is entered incorrectly. We have this little animation here, and it's good. Otherwise, it starts shaking. Here you see we have navigation for the tile menu that pops in. So there's lots of different navigations out of the box. As an engineer, you don't have to write them. You can just select the animation you want to add to it. Images and localization, there's a lot. So you see once we get to the sample, you can control what images are shown based on what toolkit you're using, as well as what operating system you're running for. The images are only added at once via Windows UI or UWP. Now they're kind of just with Windows UI. In the last 6 months or so, the Uno platform team shifted away from Universal Windows Platform or UWP into using Windows UI totally. You don't have to worry about the scaling. Like for iOS, it requires you to have 2x, 3x images, or Android, requires you to have 17 or 18 different images. You just add the scale suffix to your resource in your project, and when it's built, the Uno platform will generate those images for you. There's also localized assets, so you can add, a -ENG or a -EN or -EN ES, whatever language you want. It works like you would in a typical Windows app. And then it supports resource strings. So you write them once, then you don't have to worry about those resource strings for iOS or Android. It will generate those for you based on the resource file for the computer. Again, try to make things easy. You write it once, whether it's an image, your resource strings, or your code, and it takes care of generating everywhere else. You can reuse your library. Any .NET 2 or 2.1 library works. Most third-party controls work. You have controls available right now from Syncfusion, Infragistics, and then Lighting Chart, and there's lots of others coming soon. Your presentation frameworks. Anything that works with Windows UI will work. These are some of the popular ones: RxUI, Prism, MVVM, Cross, and then pretty much any other item in there. If you can get it in there, it works. Or sorry, not if you can get it in there. If it works for Windows UI, it will work for here. There's a list of some of the Infragistics controls that are available. So you have a full-on data grid, their gauge control, pie control, interactive charts, and interactive slider. So there's lots of available options for you. So I think that's just about it for the slides. Let's double check. Oh no, getting started. So now we talked about the platform. Let's talk about how you get started. So IDE support. Right now works with Visual Studio Windows, not Visual Studio for the Mac yet. Visual Studio Code and JetBrains Writer. There's extensions for all these environments that let you work. Today I'm going to walk you through how it works in Visual Studio. Now, next couple of slides, I'm going to kind of show you what it looks like if you're developing on Windows versus developing on Linux versus developing on Mac, because you do some licensing with Android and or iOS, things are kind of messy when it comes to building. So let's start with Windows. So if you're developing on Windows and using Visual Studio, here's all the types of apps you can build. So anything with a check mark. And I'll share a link to this later where you can see this. You have the Windows. You can build anything on Windows 10 or 11. You can build on Android, iOS, WebAssembly. You can't build on Mac Catalyst, which is the Mac OS. You can build on Mac OS if you use the Skia platform. You can build for Linux and Windows 7 using WPF. If you're using Visual Studio Code, you can't build for Windows 11, but you can build for everything else. If you're using Codespaces or Gitpod, basically only the web and the Linux-based things. Using JetBrains Writer, it's pretty much the same experience as Visual Studio. If you're developing on a Mac OS, so you have your M1 chip or anything like that, Visual Studio for Mac, you can do Android, iOS. You can't build for Windows, WebAssembly, or anything Windows, which you would expect you can't build for Windows on a Mac. VS Code, pretty much the same thing, except you can't build for Mac Catalyst. JetBrains Writer, you can build for everything except for Windows. And if you are super hardcore, like Zoltan was with pulling out his Linux box earlier and developing on Linux, you can basically build for WebAssembly, Mac OS, or Linux using the Skia setup or the Skia kit. Now, if you follow this link on the bottom of my browser or at the bottom of this PowerPoint, it will take you to some of these setup. One of the things I didn't mention, all the links will start with jjg.me/uno underscore, so you only have to take those notes. But if you're watching this recorded, you can just keep it on the screen and type away. So let's go to demo time. So I'm going to stop this, minimize this, double check, make sure there were no questions in the chat. And there were no questions, so let's minimize this. And what's the first thing we're going to do? So we're going to open up a command prompt. So here I have a command prompt. And you see two tabs here. One of the tabs has a copy of a .NET project I'm running, which just provides an API that we're going to use later. So the first thing I want to do is a .NET new install Uno templates, and I'm going to get a message that that's no longer supported, the dash, so let me just delete that. Takes a couple of seconds. It's going to go to NuGet repo, and now it just downloaded a couple. So we'll see a cross-platform Prism, cross-platform library, UI test library, and we'll cover some of those in a little bit. The other cool thing you want to do is do a .NET tool install global Uno check. Now this tool is awesome. You see I already have it installed because I installed it just prior to this demo. But I can also try upgrade. What this tool does is make sure you have everything on your desktop that's needed to build. So I'm going to run this so we can see what it looks like. You can kind of see I've run through all these tests before because in PowerShell they were popping up in the history. So I run this, and excuse me, this is because I am on a work PC, so I'm going to move this off the screen for a second. It's asking me for login credentials. If you're on a Windows PC, it wants to log in and do some things that only an administrator can do, like check certain installs and stuff. I did that, so the second screen's going to pop up, and you'll see, let me zoom in a little bit on it. It's already too late. It says, if we look here, whoa, super zoomed in. If we look here, it says, congrats, everything looked good. But if we go through the code, it first did a check-in to make sure I have the right version of JDK. That's a Java development kit. That's because that's used for the Android development. It's going to check to make sure I have a version of Visual Studio that's supported, which I do because it looks for 17.4.4 and I have 17.6.2. Making sure I have the right workloads for Visual Studio, Windows Platform, mobile development, ASP.NET. Making sure I have everything required for the Android SDK. Making sure the right version of .NET SDK is installed. I have a Linux image that I can use. I have WebView, I have long file paths, etc. So once I'm done with that, let's do a Windows reset. Once I'm done with that, I can hit enter. If you were missing something, it would prompt you to install it. So if you didn't have a workflow or anything, it would say, hey, you're missing this. Do you want me to try and download it and install it for you? You can click yes and move on. So let's see how you can do that in Visual Studio. So I'm going to pull up Visual Studio right here. I started Visual Studio without a project, so I'm going to do continue without coding. And now I'm going to go to extensions and choose manage extensions. And then online, I'm going to look for the Uno platform. Comes in, I'm going to hit download. Hopefully the internet at work is working, which it is, and it's super fast as usual. So I have to close and restart. So I'm going to close and restart that. Let's give us a second while that installs.
Hey, Joe, we do have a question in the chat while that's reloading, actually. What is the minimum Mac OS version supported for an application written with VS 2012 or 2022, sorry, on a Windows 10 machine?
What is the minimum version of Mac OS that an application written with Visual Studio? I don't understand the question. You're looking to build for the Mac using Visual Studio 2022 on a Windows 10 machine? Or are you looking for running Visual Studio 2022 on a Windows 10 machine? You clarify, Rich? I have to step away from your TV to type the question, so, or come off mute, even better. I can't hear you if you're talking, Rich. Nope, still nothing. While Visual Studio is updating, I do have a couple of links that answer some of those questions. This talks about getting started and the different development environments. Still can't hear you, Rich. I want to write on Windows and run. Oh, okay. So you can run it. The problem is you can't compile it because compiling the Mac app requires you to have Xcode. Xcode does the build. You have to have a Mac machine or a Mac machine in the cloud that has Xcode. There are a couple of public build services that can use that, but even though you can write the app and it's any version of Visual Studio 22 or anything with the Mac, you just can't compile it. And that comes into some of the answers in the fundamentals. But that's common even if you use the Ionic Mac. Yes, if you have a Mac with Xcode, Visual Studio 2022 will work. You're just going to have to compile it on the Mac afterwards. And there's the minimum version listed here with getting started with Visual Studio 2022. And then if you run Visual Studio 2022, you can take that same app and compile it. I don't think it really matters what version of the Mac OS it is. You just need Visual Studio 2022 for the Mac, assuming you have a Mac, like you just said. Answer your question? Cool. So it's perfect segue to Visual Studio getting updated with the extension. So now once Visual Studio starts, this is a funny point. This is where I always complain. Hey, Visual Studio could have started earlier if you got rid of everything that you want to use to make it effective. So here we are going to do a new project. So I'm going to start with File, New, and do File, New Project. And then you get a typical dialog box like you would with anything else. Here's blank app, Visual Universal Windows, etc. So I'm going to type in Uno here, and I'll see a bunch of Uno apps. So you can build an Uno platform app. Let's zoom in a little bit. I can build an Uno platform app, an Uno platform library. So this is an application. This is a reusable library, like if you want to build something that you can compile, like a NuGet package or something like that, you would use in a platform library. Uno platform cross runtime library runs across everything. UI test, use something like a Cucumber to test out your platform. And then you have the platform app using Xamarin and UWP, which is the older way of doing it, or .NET 6 and UWP. So for this, we're going to go and choose Uno Platform App, click Next. And let me give it a directory. I put everything in C project / Uno test. And let's call this Uno test because I'm creative with names, and give it the Uno test here. And I click create, and in a couple of seconds I'm going to get a new dialog box with the Uno template wizard. So I can choose blank and let me do everything, kind of like a blank package. If you're choosing the Windows or ASP.NET web project, you can choose blank and they won't give you anything, or you can choose default, which gives you a couple of things. So I'm going to click customize just to show some of the options. I can choose the framework. I can use .NET 6, .NET 7, or .NET 8. I'm going to just leave the default as that. What platforms do I want to run on? I want to run on Android, iOS, web, everything but WPF and Linux frame buffer. What presentation framework I'm going to use? I'm going to use the out-of-the-box one. What theme do I want to use? I'll take the default mineral or material. Any extensions I want to add to it? I want the configuration built in. I want the .NET dependency injection, HTTP, localization. I'm going to use regions for navigation. That's not code regions. And then for logging, I just want the default, whatever the dependency injection says. But I can choose something like serial or just logging to the console. Projects, you can include a server project if you want. I'm just going to include it so we can see, but we're not going to use it. This is basically if you want to build a backend API to it. What features do we want? We're going to go for everything, which provides us essentially manage NuGet. We have a toolkit that gives us some helpers, the PWA manifest, which will generate the progressive web app manifest, and then Visual Studio Code debugging in case I'm using that. We'll just keep that in there. And then authentication, there's a couple different types, web, the Microsoft authentication, OpenID, or a custom one. And then let's give it a name. So we're going to do com.company name. Let's call it GlugNet just to be different. And the publisher apparently is using my Rock family of companies because I'm using my work PC. Click create. Wait a couple of seconds. Oh, this is new. I wasn't there when I did the demo last week. So wait a couple of seconds, and then we'll have a solution with a couple of files in it. Takes a minute because it's literally creating like 15 or 20 files. And let's zoom in a little bit in the file folder so we can see. There we go. So we have this Uno test, and this is kind of like the encompass where you're going to do most of your work, where you're going to have your business logic, screens, and pages. While I'm walking through this, I'm going to kind of build the project because the first time it takes a minute or two to build. So we have our assets, our business layer, and I think my machine just froze. No, it's building, as we can see right here. So we have our assets. These are all the icons we use. Right now there's only one that we're adding. The business, as they outline it, is all the different models. Now we're going to put some custom models in here in a minute. Presentation, services, stylings. Here's the app resource string that I talked about before. Here's where you can put all of your shared things. Now that the platform is ready, it's telling you what you can do. It's like, hey, welcome, you installed your first Uno platform app. Install the Uno check tool, which I already done. Run the Uno check, which we've already done. And then if you're running the preview version of Visual Studio, run with the -free. And there's a couple of common issues. I'll put the link to these common issues. This is something that happens quite regularly, so they have like a FAQ for how to fix it. Now you see after I ran it, we got a couple of extra folders. Let's go and increase this font for a minute. Options. And we're going to do fonts and colors. And let's bump you up to 20. And then let's see, solution, I think is the next one. All text windows, let's do 20. And then command, blah, 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 autos. I always have trouble remembering where the solution one is. Let's just try that one. 20, click OK. Computer's like, no, it's too much. Give me a minute. Okay, and that did not increase anything. So let me just zoom in manually. So you see the app is basically broken into 5 pieces. Backend, platforms, the Uno test app, which is the app we just created, data contracts. This is only because the sample app comes with like the weather forecast web service, which we could ignore this. And then tests. So we're going to spend a good chunk of our time in here running. The back end, this is that sample test app that I said include an API. So this back end just works with this data contract. So you could ignore that. And that actually just delete it. And then platforms has any platform specific stuff, like for Android, if you want to have extra assets in there or change the Android manifest to have additional fields that are not available in like iOS, you can do that here. We're not going to touch any of that right now. So let's come back here and zoom out and then build. And I think I hit build already. Oh, this is a message you will get at least once the first time you open a project using Uno platform and XAML. I haven't figured out why yet, but there's a knowledge base article on the Uno site about it. You might have also noticed if you're watching the error window that says that there's an error, it can't find the file. There's something that happens once the files are first created. So I think they're all loaded now. Let's build it. Doing Control-Shift-B to start a build. And this takes forever. Take a quick look, see if there's any other questions. Nope. Let's queue for someone to write a question if there is one. I tried this.
Ask it with my voice, but is there actually a scenario where you would recommend not using Uno? Of course, when you have multiple targets to run your application on. So
I have not seen a scenario yet that it doesn't work in. I don't know if there's any that I would say no. It works. It can build apps on like Android watches. I haven't seen iPhone watches yet, but all the major platforms it has a way to build for. There hasn't been any things that stop me from saying use it yet.
Come on.
So I said the first build takes an inordinate amount of time because it's building every single platform that we have. It's about 50% done. Once this is done, the future builds will be quicker. So next step, what we're going to do is kind of show the Android app. So behind the scenes, I started an Android emulator. This is a Pixel 4. And the only reason why I chose Pixel 4 is because it fits in this screen resolution without having to play around with my default screen resolution. And it's using the Android SDK version 33, which I think is the one that starts with a T, tiramisu, I think, but I could be wrong. So we're going to generate an app that will appear here in a second or two. So we're just about ready to do it. So let's go take a look at the drop down here. You see it by default has the Windows package because that's the one I have selected. If I come through here, zoom in a little bit, I can choose Windows Mobile, Windows WASM, whichever app I want to run. Let's go. Why can't I see the other properties? Oh, I gotta choose Windows Mobile first. And you can see I can run on my local device, or I can say run on .NET Framework for iOS, run it for Android, run it for Mac Catalyst, run on a local Android device, which I just said I have that Pixel 4 API 33. It knows, it can detect that I have that Android emulator running. If I was on a iOS device, it would show me the different simulators if I had the licensing for it, or if I had the Mac Mirror that lets you mirror to a local Mac device. So it's done. So I'm going to hit local device to run. It started the build. As we see here, setup hot restart. It says this wizard will guide you through setting up to deploy a local iOS device. I'm not deploying a local iOS device. Needs to install iTunes. I guess I chose iOS instead of Android. Yes, I did it again. Let me go through and choose Android device to make sure I'm running on the Android device. And I did not accept the Android SDK. You see here I have a message that's saying you must accept the Android SDK, which I did not do because I just installed the SDK this morning. So I'm going to click accept and then run it again. It's only a one-time thing because I downloaded the latest version of the SDK and you have to accept all the legal agreements. So now it's rebuilding and going to be redeploying it over. And I'm going to pull up the Android SDK, the Android simulator, and we should see it pop up in a minute. While that's working, I'm going to go on the output window for a second. See, we normally have our build that says stuff. There's now a new one added called Uno Platform, where you can see everything that the Uno app or the Uno platform is doing. This error was the first one because I did not accept the SDK. Now everything else is just informational. It's almost done building. Next feature we're going to try after we see this is hot reload. I'm going to go and start off a bunch of different apps. I'm going to do a WebAssembly app, keep the Android one open, and run a Windows app. And I'm going to make a change to the app and show how hot reload works across the thing. So now the Uno app is running. This is the splash screen, and I get my typical name. I'm going to type in my name. I type in Joe, go to the next page, and there it is, Joe. So the app is working. I'm going to keep the emulator working and the app working, and now let's go and start some of the other apps. So let's go back to our Solution Explorer. And I want to start the WASM, which is the WebAssembly app. And I am going to choose Debug, Start New Instance, and then start a new instance of the Windows app. That was just a message about trusting the local IIS system. The dev certificates, I guess I applied an update to Visual Studio today. It's launching the debug adapter to get it ready. That one's still running. Now I should see here. Got it, blah, blah, blah. And I got another error. Oh, this is a common one. So, I forgot my notes. See where it says here, failed to bind address 127.0.0.1.5000 already in use? That's because it's a very common port number to use for ASP.NET applications. And if you remember, I told you that in my PowerShell, I have another .NET app running. This is running on port 5000, so we tried to start another app. It's actually on the Uno page also. So if we look at the Uno, it tells you if you've seen that, there's a reason for it. I think it's like one of the first or second ones. So let me go and change that. I'm going to change the properties from 5000 to another port. So here it's 5000. I'm going to change it to 5010. Save it, and then let me run that again. The reason why I did that in front of you all is to show you I'm human like everyone else, but because the first time I ran into that problem so many times and I couldn't figure out why, and mentally it was like, oh yeah, I already have something running like that. So now I should get away from that error. Now that's running. Yeah, ignore you. There's the Uno app loading, and I should have my enter your name coming up soon. Should have my enter your name coming up soon. That's usually a clue for you to start. I apologize. What's really happening behind the scenes is my computer is getting overloaded. I told you I have an API running. It's running through Docker, so one emulator to run SQL Server, and then I'm running an emulator to run the Android SDK, then throw Visual Studio on top of that, and now running another app. So it's just the computer is just dying right now. I'm going to do Joe Wasm or Joe Wash. I guess I need a shower today. Go to second page. That works. Let's go and start my Windows app. And where's my debug? There we go. Debug. Start new instance. And that one is not going to work because I did not enable the Windows Development Store. That's what you'll see here. And I have to do that separately. I think it requires a reboot, so I'm not going to do that now. Just to make sure. I'll open it up on another screen and see if it comes up. Okay, so I talked about hot reloads. Let's go back to the page and take a look at one of the pages. So all of our pages are located in the Uno test, and the pages are located in the main presentation. Let's take a look at this main page.xaml. And it looks very consistent with a typical XAML app or a Windows UI. So we have row definitions, we have a title, here we have enter your name, second page. Let's go and add another text box here. Text equals, I got to earn my street cred as a presenter, so I got to do hello world. And then let's do I remember the color code. Let's just do that for now. Hit save. Let's come back to the Android or the WASM app, which should be here. And I probably should have went back. I didn't go back because it wasn't on that page, so it's not going to hot reload, but I'm going to click hot reload and should have reloaded. Let's see if the Android app did it. Oh, the Android app totally closed. That's probably because of the error we had with Visual Studio. Well, my hot reload is a hot mess right now, and that is actually pretty common still. There's a blog post on the Uno platform page on how to handle the hot reload, or how to help and fix the hot reload. So let's go to the last demo and add in let's add in a web service. So I mentioned we have an API here that we're going to talk to. And the API looks like this. There's a contact. It has a number, a name, first name, last name, image, URL, etc. So let's see how we can build an app to do that. And Visual Studio is doing a Joe Kunk and apparently decided to stop working after the last build. Let's see if I can fix that. There it goes. It was catching up. And now I just started another copy of it. Add Joe. Add Joe. Sorry, it's running like 14 different things right now, so it's taking its sweet time. Okay, so we're back here, and we're going to minimize you for now. Minimize you. It's just going to minimize the platforms because I only care about this. Cancel you. Let's go take a look at the services piece. So before we get started with this, we are going to access a URL. So we're going to make an HTTP call out basically to my machine and then go forward. Oh yeah, we're running has the same solution going twice. So in order to do that on the Android device, you have to specify that you want to connect to the internet. So you do that by going to the Android manifest and telling it you want to do that. So Visual Studio 2022 has this neat little feature where you can edit a lot of the manifest docs for you by default. So here I'm going to say I want the required permissions to be internet, which is scrolling really far down. I'm going to check that, and that gives me permission to access the internet, or at least say that my app is going to access the internet, and then prompt the user saying, hey, this application has access to the internet. That's something you want to do. So let's save that. And now we're going to come across and add a couple of files to the solution. So because we're going to the internet and we're going to access HTTP and JSON files, let's go and add 2 packages for that. So I'm going to go manage NuGet packages. And let's just do system.htdp. And hit the browse button because that doesn't default to that. And I believe I only need to add to the mobile app because that's the only one that's going to be accessing them. Click install. That's going to add the HTTP to it. Yes. Yes. Sometimes I wish there was a way you can just hit yes, never show me this dialog box again. Next one we're going to need is system.text.json. Get that, install it to the mobile. And now we're good. Click OK, click I accept. Now we're going into here, or actually into here. I think I actually need to add that to the Uno test. Let me go and add that to Uno test, and not Uno mobile. Yes. System.htp. And add that there. That should be good. And now let's go. I'm going to add a folder here called models that mirror the models that we're going to get back. Oh, come on. I told you I accept it. Add new folder, models. Now behind the scenes, I'm going to copy those models over so you don't have to watch me type them. Okay, that's there. We should have a couple of models pop up here in a second. And then on the services, we have caching and outlet. I'm going to add a new one called contact service. And let's just take a quick second to see what that looks like. So these models represent the contact. So there's a contact with a first name, last name, middle initial, etc. They have one or more addresses, one or more phone numbers. Then we have this service, which will go out and make a call to HTTP client and call the contact service to either do a get contacts async, etc. But if you notice, I had a couple of if things. For the Android, when you're testing locally in the emulator, you can't go to localhost because that's handled by the operating system. You have to go to 10.0.2.2, which is the equivalent of 127.0.0.1. That's why I have this condition for Android. There's also for WASM, if you're building a WASM app, there's a different HTTP handler than not. And then there's one for debugging, which gets you more, I want to say more insecure, but allows you to see more stuff if you're in local development. Everything else in that is typical service. We're going to make an HTTP call and get back a response. So we have that going. Let's go and do the next part. So in the presentation folder, let's go and add something. So we're going to add a new page to it. So I'm going to do add new item. And I'm going to do show all templates for a minute because I want to make sure we're getting the right thing. So here you see there's an Uno page, UWP, all the way across the board. So we're using the Windows SDK. So I'm going to choose Uno platform to make sure we narrow it down, and then choose the Windows app SDK because now we're using Windows UI and no longer using Uno universal Windows platform. And we're going to give the page a name, and I'm going to call it contacts, and the case is sensitive, so I'm making sure I get a capital G. Click add, and in a couple of seconds I should have a new one. Now you can watch me type, or I am just going to copy and paste a bunch of code and explain it to you. So I'm going to replace this grid with a list view. Now this list view, we have an item template, and the item template has a data template with it, which basically says give you a grid, and then we're going to apply a person picture to it, which is going to use the image URL, the full name, or the initials. Ignore the grayed out part. For some reason, I can't get it to recognize that I have the right libraries on my machine, so I lose some of the ItaliCents and get a lot of underscores, but it actually will work. So it's going to create a picture of the person, assuming they have a URL. If not, it's going to display their first name if there's room, if not, their initials. And then it's going to display their first name and last name beneath them. So now we have to go and do the code to do that. So I'm going to open up my contacts.xaml, and I am going to replace this code with additional code. So let's just take out the constructor, and now we're adding to the constructor a loading event. So we're saying, upon loading, I want you to load the contacts. So when I get to this page, I want you to trigger this event, which basically you're going to make a call to the contact service, get me a list of all the contacts, and display them, or set the list view of contacts item source to that. Now, typically you wouldn't do this because there's only 500 in here. It's a demo, it's running locally. Normally you would do paging or something like that, but for this demo, we're not going to do it. And it just got dark in here because our office lights have not since we moved in a while. So I apologize for that. So let's go to the main page and give us a way to get there. So we're just going to add a button here in the stack panel and say, give me the ability to see contacts, and then we need to execute that. So let's go to main page and do the same thing. I'm going to change this. So say whenever that button is clicked, the button contact is clicked, execute this, which says frame, navigate to type of contact. So find that contacts page and run it. If I got everything right, and I run this on the Pixel, we should have the contacts app. It's not a full app, but at least it demonstrates some of the features out of the box. So let's pull up our Android emulator. Take a quick look at the questions. None yet.
I have a question, Joe.
Yep.
So this seems like a lot of setup, and I know that partially this is just because of the performance of your machine right now, but how much setup would you say typically there is when you're starting with Uno first?
The initial setup is a little bit lengthy. It will probably take you about an hour or so, depending on bandwidth and everything, to get everything initially installed on your machine. Like you saw, mine was there, but that's because I already went through Visual Studio and made sure I had everything. I went through Visual Studio, made sure I had all the stuff. I went through, had the Android Studio already on there. There's a setup guide that I'm going to show right after this demo is done, which is not working right now. But after that, once you have it running, it runs actually fairly quickly. It's just right now because of my developer PC, and I'm running an emulator and sharing my screen and video, and it's just, there's a lot. If I show you my CPU right now, it's probably maxed out
Sure. Yeah, understandable.
See, 100% CPU, 87 the disk. It's working right now. But normally, as you see, once I get it done and click play, everything's there. So everything's back to normal. It's just the initial startup and the first time you run the app, it takes a minute. But after you compile it, everything is as if it was just a normal C# or VB app.
Okay, good to know. Thank you.
So Joe, as a follow-up question, does that mean that if you decide you're going to be working in Uno on a regular basis, you need to get a real nice beefy machine?
No, it's only because I have two emulators running right now.
Okay.
I have
Okay.
Docker running to support my SQL server. So that's taking up 8 gig of memory and whatever processor speed, and then the Android emulator.
Okay.
The key, if you don't have that, like if you're just connecting to a normal SQL box or not even a SQL box, that's one less thing. But you don't need to run the emulator all the time. Like you can test it in the WebAssembly or the Windows app. If you're working on a Windows PC, that will be almost instantaneous. And then when you're running on the emulator, you then start the emulator up. But even that, first time you start the emulator up, it takes a second. But after that, it's relatively fast. So you don't necessarily need a beefier machine, but we all say that. And then we want the fastest possible machine known to mankind. And I must have missed something in the build.
Yeah, I'm probably not the only one ever, waiting for that chance to ask for a better machine, right?
Yes. I missed something in the build. Let's go to the web app or the Windows app. Let's try that. Or actually, no, I can't do the Windows app because I didn't accept the license. So let's do the WASM app. It says generator for XAML was not there. Did I miss the name of something? Let's go to my backup. Name page, that XAML looks right. There it goes. I must have messed up something in the Android app while I was adding the permissions. Okay, see contacts. Apparently I didn't get the nesting right of it. It's loading up the screen, downloading the images. If I go to here, I should see there's a call to get contacts being made. And it's loading. Come on. It's usually a lot faster than this. Full disclosure, after I ran this demo locally last time, my personal PC, I added additional memory, so when I get home, there'll be more memories waiting for me to hopefully alleviate some of these demos. My work PC is not as powerful as a normal developer machine. Come on. Let's check Visual Studio and see if there's any errors. Nope, no errors. It's still running.
So can I ask another question while we're waiting?
Yeah.
Okay. So my client approached me with the need for a new app, and in listening to the requirements, it sounded like a perfect match for a WPF app. How do you feel about doing a greenfield WPF app in today's world? And if not, what would you use instead?
I have not done any WPF development in a long, long time. Not because I don't like it or anything. I just haven't had a need. Um, the only reason why I would think nowadays someone want to do WPF app is if they want to do a very rich UI application.
Mm-hmm.
But you can do that now with Windows UI and skip over the WPF part. Uh, you can also take that one step further and use the Uno platform to do it, and then it runs on multiple applications or multiple platforms. But I would go more towards the Windows UI only because it's modern and I don't know how much the WPF infrastructure is being invested in anymore.
Mm-hmm. Right. I mean, I felt nervous suggesting a WPF app, and my research kind of led me to the WinUI path to give them a rich client, but not be, starting out behind the I don't know what you want to
I don't
call
even
it,
know if WPF
something too
is
old.
anymore.
Say again, please.
I said I don't know if WPF is supported anymore.
I don't know that it's not.
Correct. Oh, apparently it's still running.
Yeah, I think WinUI would be the path to go based on what they described. Kind of
Yeah.
like the modern choice for a WPF app would be WinUI, I think.
Cool. Well, instead of sitting there figuring out why this magically stopped working, I'm going to go to the rest of the deck, which is basically a couple of sites to take a look at. Where are we? So the getting started page. Oh, look, now it's running again. Uh-huh. I'll let that run up on the other screen, and then if it works, I'll bring it back down. The Uno Gallery, which allows you a way to go and play with the apps. You can see what the different components look like. You can look at the source code. You can play around to see what's actually there. Getting started guide for Visual Studio, which I kind of alluded to before. If you want to use Visual Studio on the Mac, Visual Studio Code, JetBrains Writer, or what have you. The welcome, which is their getting started page. How do you get started? We kind of walk through some of this stuff. This is what they show you in the Visual Studio start page. Uno Playground, if you don't even want to bother putting anything on your PC, you can start playing around here with the code. I can put data here, so I can throw my JSON file here and put that XAML here to load that, and I'll be able to see the actual interface here. So that's another cool approach. The Uno samples, and all these will be on the slide deck in a minute, show you all the different examples that you have for building this. And then last up, Windows UI 3. I found this tool very helpful, especially on Windows, and it might be helpful in your project coming up if you decide to use WinUI to download it. It shows you samples on all the different components in the Windows gallery, how you use them, what they look like, so you can kind of play around and get a feel for things. That being said, let's go to the demo time, and we've already talked about the installing templates. Here are the URLs that you can go to. I'll leave it on the screen for a second to make it easier to capture. It's basically everything I just shared. Open it up to any other questions, and or here's my contact information. I will post the sample working once I figure it out. Usually once I get done with the talk, it takes 2 seconds to figure it out, and then it's there.
Mm-hmm.
Outside of that, I apologize for the one broken demo. Any questions?
Well, it wouldn't be a live demo if something didn't break, right?
Yeah, right. I've done this demo, like I ran through it 16 times at home. Everything worked fine, but whenever you present, there's always one thing you miss.
Mm-hmm.
I even have backup copies of the code that I can really pull in, but I don't want to waste everyone's time by looking at that. Cool. Well, thanks for having me. I look forward to coming back again in the future. Maybe one time if you start doing live, I'll be in Detroit and I'll take the drive over to Lansing and come and see.
I think that would be awesome. We are anxious to get back in person. I'm reaching out to a couple places, so hopefully soon.
Well, again, thanks for having me. It was a pleasure.
Yep, thank you very
Yeah, thank
much.
you, Joe.
Appreciate it.
Wonderful. So, as mentioned earlier, we do have a survey for everyone to fill out. The link is in the chat. I will also send that out via email. I will leave that survey open for about 24 hours, at which point I'll close it and get you the summary of the results, Joe, so you have all that feedback.
Thank you.
All right. Well, if there's no other questions, we'll let you get on with the rest of your evening. Thank you very much, everybody. Have a
Yep,
great night.
thank you. Thank you
Bye-bye.
again. Bye-bye.